to my channel Bal Vigyan Varde, and here is your mentor Avilash Sarkar. In the last video, we are talking about instantaneous motion of a translation in translation motion, and that part is over. The theory part. Now we will solve some problem to clarify the things better way. Okay, so let me describe few more problems. The first one of it is a displacement in bracket it is written as x, so their displacement is represented in the form of x of a point moving on a straight line of a point moving in a straight line. So that means it is talking about the translation motion. Straight line is given by x is 8t square minus 4t. So that means x is a function of that I have described in theory, that if displacement is a function of t only, then for instantaneous motion we can we can derive the velocity or acceleration. So this is in given form of t, a dependent of independent variable t. There x and t both are variable. Then the velocity of the particle is zero at what time? So you have to find the time at which the velocity is zero. So solution will be, so as you know, your velocity is nothing but the derivative of dx displacement with respect to time. So now your as I said, x is a function of t, so that is the I will do derivative of this whole function. So now as I said, the derivative of something plus something or minus something, it would be derivative of with respect to t. If I say a and b are the two different terms being related together is in this way or minus, so this can be written as derivative of a plus minus derivative of t. So these are the scalar function, you can say, because these are following the method of scalar summation or subtraction. Okay, so so you can differentiate the formula in this way. Now also I said that derivative of constant into some function, let's say x, so that is nothing but constant into the differentiation of this the variable. Okay, so 8 can come out if it is t square. So as per the formula, that d dt on t nth power, so that will turn into, this will be result here, 2 is there into 2 t to the power 2 minus 1 minus 4 will come out t, this 1 will this is power of 1 t to the power 1 minus 1, so this is 16 t ultimately minus 4 t, 1 minus 1 means 0, something power 0 is 1, so that will turn into 1, so ultimately this will be this one. Now the thing that I have to calculate, then the velocity of the particle is 0 at what? So this is the next part of it, where I have to, so just remember this last equation. So that is your v will be v is denoted by 16t minus 4. Okay, so this will be the ultimate equation. Now as per the condition, velocity should be 0. So if I put v is equal to 0 here, if I put v is equal to 0, that will be 16t minus 4. So 16t is equal to 4. So t is equal to 4 upon 16. So that means 1 upon 4, that means 0.25 second, because t is in second. So that is the requirement of the sum. At what time? That means at 0.25 second, the velocity for the equation given x is equal to 8t square minus 4t, sorry 2t, or 4t was there, yes, 4t, the velocity will be 0 at this time. So this is the sum. Moving to the next. Sorry. The next problem, if number 2, if the velocity of a particle, the velocity of a particle v is given by at plus bt square, where a and b are constant. Okay, these are constant. Then the distance traveled by, then the distance traveled by it between 1 second and 2 seconds. What would be the distance traveled between 1 second and 2 seconds? That means whatever be the graph of the motion, so there is the time lag where this is 1 second, this is 2, in between the distance traveled. So that you have to calculate. Now from the equation, if I say if v is such that velocity is given by this one, so again the solution, that v is given by at plus bt square. So v is what, we can write it dx dt. That means velocity is nothing but change in displacement position by change in time, means this is differentiation of displacement against time. V is equal, so that is equal to given by at plus bt square. Okay, so from there I have to establish the equation of displacement. Now this can be done by the process of the reverse of the differentiation. Means if x is a function of t, so I can find dx dt is by differentiating that function with respect to t. So this will give v. Now reverse of that, if I want to find the function of t, okay, so this can be written as function of d is equal to v into dt. So this is the process where I will do integration. Means if something is broke down into the lower value, that being done by the process of differentiation, whereas to integrate that means to assemble that, we have to use the integration. So this is the process just opposite to the process of differentiation. So by differentiation of displacement, we are getting velocity. By integrating that velocity, we will get the function. So how do you do that? Now dx is a function of whole differentiation of t. Now for doing integration, is always need some limiting value. Between that function will vary, means this is the limiting condition. If not, then I will do it for any value letting be between two extreme. So if I consider the two extreme be the variable x, okay, so I will get the function only by differentiating without any limiting condition. That means I will not get any limiting condition, rather in an instant of time, if I can get the function this graph, and if I put this value of any condition, any point of time, I will get the value of that graph at that point of time. So I will not make it a boundary, and I will not calculate it for the boundary, rather I will calculate for an instant of time where this is t for value, I am assuming it is x. So what would be the case? So integrating this dx will give you value x. So that you remember, because when you differentiate x, I will get dx. So integrating this means I am accumulating all those, so I will get x. Okay. Similarly, as differentiation constant won't change, here also constant won't change. I can keep the function separate as I did in differentiation. This is just the reverse, but that will integrate. That means that will increase the value. So this can be written as this one: a integration of t dt and b integration of t square dt. Now, just for now, remember these are the formulas. When I will cover the integration chapter, there I will explain further. But as of now, dx become x. Now this function changes in the form that t will become 1 plus 1 by 1 plus 1. Okay, so this will change like that. That means integration of t to the power n dt, that will change into t to the power n plus 1 by. So remember this. Remember this formula. Integration of t to the power n by dt will become t to the power n plus 1 by n plus 1. So and the second one is b t to the power 2 plus 1 by 2 plus 1. Okay, so this will be the case. So the ultimately it will become t square by 2 plus b t cube by 3. So this will be the function of x. Ultimately what I will get x function as a t square half, you can say, plus 1/3 b t cube. This will be the function of x with respect to time. Now I have to find the distance traveled between 1 second and 2 seconds. So if I put consecutively t is equal to 1 and 2, so x1 for t is equal to 1, it will be a by 2 plus b by 3, and that for t2 2 seconds, let it be written as x2, it will be 2 square means 4 by 2 2a plus, if I put 2 here, 2 cube means 8 by 3 b. So this will be your second equation. Now this is x2, this is x1. X2 obviously be more because that comes in the later part when it has moved by second. So x2 minus x1, the distance will be plus 8 by 3 minus 1 by 3 b. So that is equal to 2 to the 4 3 by 2 a plus this is 7 by 3 b. So this will be the distance, that means delta x between 1 and 2 seconds. That can be represented with the constant of ab, because one value of ab is not given. So the thing will be written as 3 by 2a 7 by 3. So this will be the case for this. Okay, moving to next. Number 3. The position of an object, the position of an object moving along the axis, the x-axis is given by x is equal to a plus bt square, where a is equal to 8.5 meter, b is equal to 2.5 meter per second square. So that means a is a constant which is in linear dimension. That means it is representing the displacement, you can say, and v is a constant that is given in meter per second. That means acceleration. Meter per second square is a unit of acceleration, and t is measured in second. That means t is time. It is representing its velocity. Its velocity at t is equal to 2 seconds is how much? So this you have to calculate what is the velocity at t is equal to 2. So now the acceleration, your displacement equation is given by this. So as a and b supposed to be the constant, because this is a the fixed value is given, so you can consider this is a constant, and t is measured in second, is velocity. Now what I will do, as x is given in form of t square, so velocity can be calculated by differentiated x with t. So this is constant, that means it will be 0 with respect to any derivatives with any independent variable. So if I do dA by dt, that will give you a constant, and here constant is b will be as it is, and t square, you know, that will turn into 2t 2 minus 1, that is equal to 2t. So ultimately this will be 2bt. So that is equal to velocity. Now its velocity at t is equal to 2. Now obviously if I put t is equal to 2, now I will get the velocity at t.0 second. So that is equal to 2 into b is already given. So b is 2.5 if I put it here, and t is equal to 2. Now see the how the things can be calculated, because here everything is given the unit. So if I keep the unit also with along with that 2.5 meter per second, so I will keep it as it is, second square, and for t here is second. So ultimately you can see whatever be the numerical value here is 4 into 2.5, that means equal to 10. Okay, but the unit, it is meter per second, which is a unit of velocity, you know, in kinematics I already learned. So see, even if it is not given for any such equation, the constant part here you can consider this is t square. So definitely this must be something in meter per second. So because t square is a second square, and meter per second square will be cancelled, it will give you meter, and this must be meter. So unit is very important to understand, because that equation is not a very erratic equation. It is have some basis. X is given in meter, so this all part in the other side has to match dimensionally along with the unitary, means whatever the unit is there, that also a is not is associated with an t. If it is associated with t, there must be meter per second. A must be meter per second then. If it is not associated, this is directly meter. So this constant have some meanings. So you have to understand the units also along with the sum. Okay, this is the significance of giving the constant means unit of the constants also. Okay. So now next is 4. For a particle displacement time relation, for a particle displacement time relation, is given by t is equal to root x plus 3. Its displacement when its velocity is 0. Find its displacement when its velocity is 0. Now, prior to that, as because it is given in the reverse way, means t is a function of x then, but I know the velocity has to be the dx dt. So that function has to be converted into such a way that I will get a order of 1. X should be on order of 1. Here x is the order of half. So x root x can be written as this. So if I square up both sides, so x can be freed from that square root, and here it is by this. Now if I do dx dt, that means if I want to calculate v, that will be 2t minus 6 and this constant is equal to 0. So now v is equal to, giving this equation, now find its displacement when velocity is 0. Now condition is v is equal to 0. If I put v is equal to 0, what do I find? 2t is equal minus 6 is equal to 0. So t is equal to 3. That means velocity will be 0 at t is equal to 3. So if t is equal to 3, if I put in the in the equation here, so what does it mean? X is equal to 0. That means at t is equal to 3, velocity is 0 and displacement is 0. That means how it is possible? Velocity becomes 0 after some second, but displacement, how come it is be 0? That means that motion may be a linear motion against gravity. That means it has started from some point, moved to a distance and fall down again and meet the ground again. So that means the total displacement against the ground is 0. It's possible, and the velocity when it is striking at ground, it also be 0. But this total time of travel is 3. That means one and a half second it is moving up and down. So this can be possible. If you have to been asked to describe how the things is possible, where after second x is 0 and v is 0, because x when it is doing some journey it must have some displacement, but here it is 0. So this is possible where this kind of thing is happening, or else it can be a circular motion. It's starting from a part and moving and then slowed down and become 0 here. This is also possible. That means that total displacement is 0 when it is coming back to the point, start point of the journey. Okay. Moving to next, there may be so many problems. Let me check if it is a different one. The position of x is a particle moving along x-axis. Where is the time? It is the meters and t is the second. Particle reverse its direction of motion. The particle reverses direction of motion. Okay. 0, 5. The position x of a particle the position x of a particle moving along the x-axis varies with the time as x is equal to 20t minus 5t square where x is in meter, x is in meter and t in second. The particle reverses its direction of motion. The particle reverses its direction of motion. At what time? So that means that motion must be such that it is coming back after some time, it is reversing back. That means this is possible for the motion is against gravity, or the motion when it is rebound back from something, such as the ball is rebounding back from a wall. So this kind of motion, when x, if it is x is positive, so it is reversing, so x would be negative. So what is the time it is possible for that? Okay, so now you see when x is reversing that its direction, that means velocity also changing its direction. That means if this is velocity v positive, this will be the negative v, velocity will be negative. Now the point at which, so before it become positive to negative, there must be some position where v must be 0. This case also, when it is, let's say this is positive, okay, and this is negative, because or it can be because against the force this is positive, and when it is, let's say this is positive, that this must be negative. So because at some point of time it must be in rest, after that it again moving down, as because this direction if I can take positive, this must be negative. So this way this displacement, no, this must be as per the dimension of vector. This is moving against the force. So against the force, the velocity displacement will be negative, then velocity will be negative there. This will be positive. Whatever be the case, means it is moving, and when it is coming back, when it is changing its direction, there must be some velocity where the velocity, the extreme velocity will be 0. Okay, this is starting velocity, this is moving velocity, this is ultimate velocity, 0. That means this has to be negative. That means velocity is reducing, then after it is positive. But at point of time when it is reversing its direction, that velocity will get 0. So this is the point where we are talking about that particle reverses its direction. So particle at the point it is reversing, at that point, that instant point time, velocity must be 0. So this is the clue for the sum, and the rest is very easy. Now what you have to do, you have to differentiate this one. 20t minus 10t will be the equation. This is v. Now v is equal to 0 if you put, so that will become t is equal to 2. If I put this v is equal to 0 here, so my time, so this is the requirement, the particle reverses at what time? So time is equal to 2 seconds. After 2 seconds, the the direction of the motion will reverse. That is the answer. Okay, so this much today. There may be so many problems, all is not possible to discuss, but there may be variety. But if you can understand uh, the theory well, you will be able to solve it easily. So try at home. If any problem, you can put in comment section. I can come to solve it, or I can help you, give you some clue, so you can try afterwards also. So later I will move to the other subjects from the next session. Thank you.